So, kind of the opposite of kinetic energy, energy associated with motion, is potential energy. Potential energy is stored energy. So, the way this works is the higher you lift an object from the surface to which it can fall, because of its position, it actually has, because of its position to fall, it has what we call stored gravitational potential energy. And how much stored gravitational potential energy does it have? Well, it has the mass of the object that you lifted up. G is that 9.8 meters per second squared times the height you lifted it up. So basically, the way what I'm saying is, if this is a box, we'll call this location A, and if you go ahead and lift it up, we'll call this location B. It's the same box. I know it looks different, but it's the same box. Now it has more potential energy. Why? Because of its ability to fall, and this is the H that we're talking about here. So let's do one of these. We have a picture of a beautiful apple, and we're supposed to come up with how much gravitational potential energy does this apple have if it is located 1.2 meters above the ground. So H is 1.2 meters. The mass of the apple is 0.14 kilograms, and of course we know what G is. So potential energy is equal to mass times the acceleration due to gravity times the height, which in this case is 0.14 kilograms times G, 9.8 meters per second squared, times H, which is 1.2 meters. So plugging that into your calculator, I get, my calculator displays 1.6464, and units of energy would be joules. Notice that if I want to, oops, now I noticed something. Do you see it too? This is kilograms. This should be kilograms. I caught that because notice that if I take these units, kilograms, meters per second squared, and meters, I get units of kilogram meters squared per second squared, which are joules. So if that's what my calculator displays, I'm thinking it looks like I need to round to 2 digits, kind of across the board. So I'm going to keep this digit and this digit. I'm going to truncate it there. And since that's a 4, I'm going to leave the 6 the way it is. So to me, the answer, rounded correctly, is 1.6 joules. That's it. Is the stored energy related to the position of that apple. So now we have a video question. So we're going to go ahead and, what if your apple is honking heavier, 1.31 kilograms, and it's hovering a distance now 4.2 meters above the ground? What is its stored potential energy due to the force of gravity? So go ahead and work this out, but I'm just telling you potential energy is the mass of the apple times G, which is 9.8 meters per second squared, times H.